Hello everyone, this is Joseph Porter, your host, and you're listening to The Next Layer. In this podcast, we're looking to explore the world of additive manufacturing, from hobbyist applications to complex engineering solutions. Our focus is to not only learn about the current state of the market, but where it is going and how individuals like you and I can take part in these trends. We'll be interviewing hobbyists, engineers, and scientists, discussing new techniques, applications, technology, and discovering what the future of additive manufacturing will entail. Whether you're an aspiring creator or a senior research scientist, we hope that you listening are able to learn something new. We'd like to thank our sponsor, MarketList.com, for making this episode possible. MarketList is an online contract bidding platform for additive manufacturing where local manufacturers have access to a wider range of work that they can bid on, and clients can receive offers that best fit the needs of their project. If you're interested in saving time and money on your next 3D printing project or taking on more clients for your business, stop by MarketList.com. The link is in the show notes. In today's episode, I have Alex Schepelmann, who is a NASA engineer and also the creator of Super Make Something. In it, we discuss what it's like to work at NASA Glenn and the different projects like 3D printed robots they have going on there. We discuss his PhD thesis, which is creating a robotic version of the human leg and 3D printing parts for that. Then we dive into Super Make Something and several of the projects he's created for it, which are very cool. Then we talk about how to get started with the world of robotics and electronics projects and 3D printing, different tips and tricks for 3D printers, and where we hope to see the market go. Thank you for listening, and I hope you enjoy this episode. So I've got Alex here from Super Make Something and also a NASA engineer. Alex, why don't you tell us a little bit about yourself?
Yeah, sure. So thank you so much for having me on this podcast. And in general, I kind of have two hats. So during the day, I'm a robotics engineer at NASA Glenn Research Center, working on new tire technology in the Slope Lab, where we kind of have a lunar simulant test bed and test a bunch of different tires and tire performance to hopefully build the next generation of rover tires that'll roll around on the moon and Mars. And then on the weekend, I'm the host of the YouTube channel Super Make Something, where I make basically DIY maker projects that involve 3D printing, laser cutting, and various other kinds of technologies. And the hope there is to basically show people the fun that can be had with additive manufacturing and electronics, and hopefully teach people something that they didn't know before, and just get them involved in science, engineering, and things like that, to hopefully get people excited about making stuff.
For all those who are listening, if you have not checked out this show, definitely take some time. The link is in the show notes. Hop on there and just watch these videos. They're amazing. Even the lo-fi 3D printing music is awesome. I listened to that for an hour the other day. Great stuff. So definitely check out his show. This thing is fantastic. So let's talk a little bit though about the work you do at NASA. So you said the Slope Lab, you're working on tires for the next lunar rover. So what exactly does that entail? What does that mean? What all do you work on there?
Right. So I recently joined the Slope Lab, and basically what we're working on there is we're helping NASA characterize the performance of various rovers and various tires that are hopefully going to be on the moon and eventually Mars very soon. So the idea there is basically that historically NASA has used solid tires machined out of essentially a giant block of aluminum. And what that leads to is obviously you can't have pneumatic tires on the moon or on Mars in case they would get a flat. So kind of the solution that NASA had employed for the current Mars rovers is to have these basically solid tires, which are basically just tire rims and structure. And in general, that works really well. But what engineers noticed was that the tires were taking a lot of damage just by rolling over the Martian terrain. So it's pretty rocky, pretty aggressive. And we see that actually with the rovers being able to take selfies essentially of themselves for diagnostic purposes, large chunks of that solid aluminum tire were missing. And eventually the concern is that, if the tire gets damaged enough, or the wheel, I should say, gets damaged enough, that could lead to a premature end of mission, and that would limit the science that we're doing. So what we're doing at NASA Glenn is we're investing new tire technologies that kind of harken back to the 70s lunar, I guess you can call them moon buggies, I guess that the astronauts rolled around in. And what happened there is they actually created tires using a metal mesh. So since then, the technology has advanced a bit, and we're now working on a new type of tire that uses a different type of alloy. And the hope there is that we can basically, one, increase the performance of the rovers, but then also, extend the mission life potentially and have them be able to explore terrain that's a little bit more aggressive and a little bit more extreme to hopefully return the science that we get when we send up a rover to Mars, for example, and hopefully that'll lead to a lot of new scientific discoveries.
Wow, that's truly amazing. How does it feel that you're working on stuff that may make it all the way to the moon? Something that we kind of always, I would say, grew up with, like, looking back into the history with all these different missions that went to the moon, and so part of, the greatest generation, especially with all the launching they did with the astronauts. Like, how does it feel that you're now a part of that?
Right. I mean, the feeling is just incredible. I mean, since I've been young, I've always loved space and engineering and science, and just to be able to be part of that now and kind of contribute to that is amazing. I remember back in the 90s when I was, oh geez, I must have been maybe 10 years old, 12 years old. I remember when I went to the Great Lakes Science Center. They were holding an event where they were live broadcasting the rover landing on Mars, and just how excited everyone was, and just the feeling, kind of to think that something that people built is now on literally another planet, and it could be there for us and explore things for us, and hopefully help us get ready for an eventually a manned mission. And now just seeing how the technology is progressing, both in terms of launches, both again from NASA now going back into space and launching rockets from U.S. soil, as well as private companies getting in on the action. Just being able to contribute to that and hopefully, work towards that mission of eventually having people step foot on Mars is incredible. I mean, it's just a giant honor coming to work every day and being able to, contribute what I know to this project to hopefully advance science for the benefit of everyone.
That's amazing. And I think one of the cool parts too, about NASA Glenn in particular, is that front entrance where it says, was it science and technology for the benefit of all?
That's right. Yes.
Yeah. Oh my goodness. That's
yeah, it's definitely a cool place to work. And the people, I mean, you work with some of literally the brightest people that I've ever met, and just to be able to interact with them every day and just share ideas and come up with new concepts that we think, could improve over the technology that we currently have it's amazing. It's fun just coming to work every day and just literally learning something new, which is just awesome.
That's awesome. So, what's like one crazy story, I guess, from working there at NASA, or just like one of your favorite moments thus far?
Sure. So I actually haven't been there that long. I actually just joined NASA in September,
Oh, wow.
but I kind of was involved previously as a contractor at NASA. But I would say in this new role, I think the thing that's been the coolest to me was just really learning how many people across all centers are really working together to this common goal to get people on the moon. I know, being in Cleveland, growing up in Cleveland, a lot of things that I heard was, oh, like Cleveland has a NASA center, and people were really surprised about that. But now it seems that the center is definitely getting more well known. I feel, especially now with this kind of renewed focus on getting people to the moon and Mars, and just being able to just learn about all the different technologies and all the different people and all the different companies supporting our basically goal of reaching space is just it's incredible to know kind of how big the team is that's all collaborating on this single focus. And it really gives me hope that we're going to be able to do great things and hopefully keep doing more cool things.
I mean, I'm being a Midwesterner myself. I'm actually from Indiana. It's just kind of growing up and seeing how the Midwest kind of declined over time. Let's say in like kind of an industrial area, especially following off World War II. But to see in the pockets of the Midwest where technology is just making a very strong comeback. And in Ohio, of all places, too, it has an extremely strong history in aerospace.
That's right.
From first flight to also some of them, like most of the like a decent amount of astronauts have come from Ohio, and just there's a very rich history of NASA being there and all the aerospace industry, AFRL down in Wright-Patt Air Force Base, and it's a very, very cool state overall for the aerospace industry.
Absolutely, and just the region too. I know Pittsburgh is also big in the robotics field, also, and just to have this basically this collection of great talent in the Midwest, basically so close by, is awesome.
It's very true, very true. So, with your work at NASA, do you all utilize 3D printing at all?
Yes. So we use 3D printing in a couple of ways. So for the Slope Lab, primarily we use it for a lot of prototyping purposes. So for example, one of the rovers that we have in our lab is called the Lunar Rover Optimization Platform, or LROP. And essentially what that robot is, it's almost entirely 3D printed. So we have metal scaffolding and some robotic actuators, but basically the configuration of that robot, all the joints and everything like that is 3D printed and made with additive manufacturing. So that's been really nice because it allows us to really conceptualize ideas kind of in a physical form. So if we have an idea to, maybe we want to rearrange the actuator topology of the rover, or we want to maybe add a feature, add a mount, being able to use additive manufacturing just makes it super easy. I mean, you just design the part that you want, even if it has a relatively complicated 3D geometry. And then we print it, and we can literally have it on the rover a few hours later to test out. And that's awesome.
What type of 3D printers do you use for all this?
Right. So we have a couple different 3D printers at NASA Glenn. So a lot of them are kind of maybe similar to what you'd be or what listeners would be familiar with at home. So we have a lot of FDM machines, but then also some of those FDM machines that we do have, they're a bit more specialized, and they print kind of carbon fiber infused materials and things like that. So really, being able to make high strength parts. Again, just additive manufacturing without having to visit kind of a classical machine shop and having to make drawings and things like that makes turnaround time really fast, and makes prototyping work super easy, which again just accelerates the science that we can do.
How did you get to this point? What's your background leading up to this point?
Sure. So as an undergrad, I studied mechanical engineering at Case, and I got a BS and MS in Mechie from Case. And then I went on to do a PhD in robotics at Carnegie Mellon. And there I worked on building legged robots and actuators to help basically test new neuromuscular inspired prosthesis control ideas that our lab had developed. And kind of halfway through grad school, I kind of additive manufacturing really started to hit it big. So kind of right around midway through grad school, I got my first 3D printer. It was a PrinterBot Simple. That was, one of the kind of old ones that were basically with laser cut parts, and then they didn't have anything like a belt drive or anything like that. But the things that move the axes were literally, sanding drums and fishing line. But even that, I mean, and it was a kit that you had to build kind of completely from scratch. But even that made, making parts so much faster and so much easier that we could just prototype. And it kind of took off from there. So actually, kind of some of that additive manufacturing work led to some of the research focuses that I had in grad school. So basically making torque sensing actuators where the force sensing element was 3D printed and then also cast and molded. And that allowed us to basically make these highly dynamic actuators for making robots that could have the basically same dynamically scaled performance of a human leg. And then that work led me for a while to do a postdoc at a startup that spun out of Carnegie Mellon that also used similar technology to make these torque sensitive actuators. And then eventually kept going. So came back to Cleveland, started working for an aerospace company here as a contractor, and then learned about some of the robotics work at NASA Glenn, and then really wanted to be a part of that. So that's kind of what led me to this point where I am now.
Wow. So did you say you basically with your PhD, you worked on creating a robotic version of the human leg. Is that what you're saying, or could we?
Yes. So basically, what we were doing in the lab was we had our lab group had developed these neuromuscular locomotion controllers, where basically instead of using kind of some classical control techniques that are used in prosthetic devices like position control or impedance control, where you basically have a set of feedback gains or you're trying to follow a prescribed torque profile. These neuromuscular controllers, what they did is they basically had virtual muscles built up in simulation that then interacted with each other to generate walking motion. And what we found in simulation was basically that they were very robust to various locomotion disturbances. So, for example, if they tripped, they were able to recover, or if they were kind of pushed in the right way, the simulation would be able to run, all just by having these virtual muscles basically interacting with each other. So our thought was, this is in simulation at least a very powerful controller. So we wanted to see if that controller would also work on hardware. So what our group did, and what one of my main focuses was during grad school, was to basically build a robotic leg that had a similar performance to a human leg within the simulation, though we use dynamic scaling to basically make it smaller and easier to work with. And then the idea was we would basically build one actuator to stand in for every virtual muscle in that leg, and then use that virtual muscle model to basically control the torque signal for each actuator, and then have those actuators basically dynamically interact with each other. And so my basically, or a large chunk of my research focused on basically building this leg, testing some controls specifically related to foot placement. So for example, if you tripped a leg halfway through a swing leg motion as you're trying to place your foot, would you still be able to basically place your foot where you wanted to place it? And then as part of that, to realize that technology, basically worked on creating this actuator technology that was able to sense force that the actuator was generating, and basically making that small enough to still fit within the size and weight envelope that you would expect for a human leg. I should say, I guess, so a large part of that leg was additively manufactured too. So, like the leg structure itself, and as well as some of the elements of the force sensor. Without additive manufacturing, I think the work would have been a lot slower, but also a lot more difficult. And just having that technology available just removed so many design constraints, that we were basically able to build this leg, I guess, with a small team of people, kind of throughout the duration that it usually takes for someone to complete grad school. So definitely without 3D printing, I don't think this project would have been possible. So I'm definitely a big fan of additive manufacturing.
Honestly, that's the beauty of it, is you can just make these super complex structures in such a quick amount of time, if you have a capable design team, and the iterations and everything is just so fast. When I was in grad school, doing different 3D prints for the encasement of optics and different units and stuff like that. And it was just, it was so nice being able to iterate through several different 3D prints to work on tolerancing or different vignetting problems or stuff like that. And it really has just, I would say, it's really advanced research as a whole, especially in grad school, because of how cheap it is to make a part, which is the beauty of it. So it doesn't really have a heavy budget constraint when you're constantly iterating through different parts, like saying going through a machine shop, even with that on time, which is just so cool.
And I'm sure you've experienced that too, right? You send off a drawing to a machine shop, you think it's all correct, and then you get it back and the tolerance is just a little off, and then either you have to go remanufacture it or at least edit it, and that's always such a bad feeling, I guess, that that happens. So with 3D printing, certainly you want to try to get it right the first part, but definitely the cost of maybe not getting it 100% correct the first time is definitely a lot less. So even for small prototypes that would eventually get machined, just with the tolerances now that you can even get with hobby machines, I almost find myself just 3D printing everything just to make sure I have a good understanding of the shape and the overall size, and kind of that I'm able to hold it in my hand before, finally pulling the trigger and saying, okay, now let's go make this out of metal or aluminum or something else. So
Yeah, and I think that's the main point they hit on there that a lot of people don't realize with prototyping. There's always this kind of this question of why not just design it once and write and then ship it off. And there's always something when you're working on engineering that's complex enough. There's always going to be something detailed that you miss in the design. Something just offset by a hair, like you said, some tolerance that you missed in the CAD design. There's always something. I've had it multiple times where, you send the part, like you were saying, you send the part off, it comes back, and the hole, that you needed for their specific screw to fit is off by like, a quarter of a millimeter, and it just messes up the entire design, and then there goes like a month of your time. It's so painful. But
and especially in grad school where the funds are super limited, so the pressure, I feel like, is almost always on, where you have to go outside and you don't have like a dedicated machinist kind of standing by at all times. So
yeah, you can't
being able to just sanity check stuff is so much nicer.
yeah. Oh my goodness. Yeah, doing fit checks and whatnot, just a beautiful part of additive manufacturing. And I think that's like a huge key when it comes to prototyping and why it's taken off for different prototyping designs. It's just the ability to hold it, look at it, flip it around and be like, oh yes, okay, this is exactly what I wanted before. Once you, like you said, pull the trigger and get it made, something more expensive. Especially, I mean, there's some optical components out there that you work with, some of the metals and stuff like that are so darn expensive and take so long on the lead time that you really want to get it right the first time before you do anything, or something in that's experiment that you need a custom part or something, it's just all these different things. So I 100% agree. It's been so nice, with the advent of manufacturing. Can't imagine, you'd almost have to have, a full level like technician, training as well to be able to go to a machine shop and get all the parts you need just in time. And if you don't have that magic technician, there's been a few places that I've worked that have had these guys that work in the machine shop, they're just wizards with aluminum, and they can get you a part pretty quick. But if you don't have that, oh my goodness, who knows when it's going to come when you get your part ready. So, yeah, that's awesome. So, let's see here. So when it comes to, let's talk a little bit about then Super Make Something. So this project you started when you were in grad school as well, correct?
That's right. So it started basically as a kind of way to do two things. So the first was, with grad school kind of being these long overarching projects, just being able to justify doing small projects that I could, quickly see from start to completion, just to maintain some sanity, I guess, to say like, oh, like I started this project and I finished this, and it's great, just because, research is always ongoing in grad school and it's never quite finished. Basically until the very end when you're ready to defend your thesis. But then second, it was also a good way for me to explore different types of technologies, and especially additive manufacturing. So it started off as essentially a channel where I would, make these small projects that involve 3D printing or, other kind of quote unquote maker technology that was available at the time, like very early CNC machines and kind of automated vinyl cutters, things like that. And basically being able to use that technology kind of helped me understand kind of the limits of, what I could do for the designs that I was making in grad school, and then helped me kind of understand better, what design choices I should make for some of my bigger projects at school, to make sure that, we could kind of successfully build what we wanted to. And since graduating, I basically kept that channel going. And really the way I approach it kind of has not really changed. So it's essentially a long form sort of video blog where I pick a project, and then basically everything that I need to make that project and how to build it, I basically explain in a video step by step. And that one helps me kind of solidify kind of my understanding of, the project that I'm building. But my hope is also that, it really gets more people involved in the maker hobby and getting interested in, engineering and additive manufacturing and things like that as a whole. Just because there are, for some people, such barriers to entry. Either if they're financial and, they might not be able to kind of afford to go to the school that they want to, or, they think that maybe a topic is too hard when you hear somebody say like, oh, I program. Like people think that programming is very hard, or that electronics can be hard. So my hope there is really that, I show people, one, that it's not hard, but then two, that, as long as it's exciting and interesting, and you kind of have the right seed to basically get started. That anybody can do it. And I really hope that, at the end of the day, regardless of how many views I get on my channel, that, whoever is watching my channel or watching an episode that I do, whether or not they end up subscribing, my takeaway is hopefully that they've learned something new, and that I've maybe inspired them to, pick up an Arduino, or, look into learning how to use CAD to 3D print their own models, and hopefully just inspire them to explore engineering a bit more.
There's such a cool means of going about it too. I mean, I've looked at some of these episodes, and they're great about how they do exactly what you want them to do. Is I guess what I'm trying to say, because I've when I first came into college, my background was not at all remote engineering. I've never programmed before. I never had a computer. I never touched an Arduino. That was like a terrifying class for me, learning how to program and starting in Python, all this stuff. So it's really cool to see that you're working into this area for those who aren't experienced, because it is very intimidating when you first start out and you see all these different things, like you're like, what is a Raspberry Pi, or right. Or how, what is variables, or how do you make all these things work? But I mean, you do a great job of explaining these projects and how, how to go about them in a very succinct way that anyone can build them.
Yeah, and similarly, I guess so kind of I started, and basically I would have to say probably the channel started kind of in a similar way. So my first exposure to microcontrollers as a mechanical engineer was a systems engineering class I took at CMU. And the goal there at the end of the class was to design a project that we could display at the Children's Museum, and that it would be on display essentially for a week. And, it had to survive, and it had to kind of work in the constraints of being able to teach someone something. And obviously CMU and robotics program being very heavy mechatronics focused, obviously, but also a very big programming focus. Kind of before taking that class as a mechanical engineer, I always thought like, oh wow, I know how to program, but programming like embedded systems can be very complicated, and it seemed scary. But as part of the curriculum in that class, they basically gave us a Spark Fun Inventors Kit, and they said, for this assignment, basically do all the lessons in the manual, and then at the end of that, use it to build something cool. And just being able to walk through it step by step, and the Inventors Kit was really great, and I think that homework assignment was really great. It really showed that programming a microcontroller wasn't really that hard, and wasn't really any different from other programming, but also that it was really fun. So just because, as opposed to just writing a program, at the end for this Inventor's Kit, you would have a servo move, or you could make a light blink, and you could really see something physical and tangible. And kind of once I saw that, I thought, wow, I really want to pass this knowledge on. And kind of that's why a lot of my projects now skew into the electronics realm. So, using Arduino, using Raspberry Pi, and coupling that with 3D printing to do things like make robots, and to teach people basically how servos work, or how a pull-up resistor works, and kind of just these fundamentals. I really want to kind of pay it forward, I guess, to show, that anybody can learn it. And even though it does seem scary at first, it really isn't. And it can actually be a lot of fun once you really get into it and have a goal in mind of something that you want to build.
Yeah, and honestly, there's nothing more satisfying than when you first get that Blink program to work for the very first time. Yeah, a little like I remember that thing frustrated me for a while when I first got into programming with C on a little PIC 16. Mm-hmm. But oh my goodness, yeah, those little programs, or like, well, yeah, watching a servo turn an arm or something, it's just a wonderful thing, and to be able to pass that on is an absolute. Wonderful, you're doing a wonderful means about going about it, and those are skills that can really apply to so many different things, and just wonderful hobbies, if not jobs. And it's a great way to start into so many different areas of life. And especially nowadays, you can get these kits, like you're saying, the Spark Fun Inventor Kit. And there's all these different kits that are out there. For those listening, if you have never delved into this world and want to get started onto a little electronics project, or just some little projects in general, these kits offer wonderful means of getting into this world as a whole, and getting started on these projects and learning about them. And you can, one of the cooler parts of it is you get to keep all the parts, and you can go build other random things, which is kind of what usually tends to happen. And it's always just a lot of fun being able to work on stuff like that. So in your episodes, what I've seen here, you have about, I think it's like you have a bunch of them on 3D printing. But one in specific that I noticed was about toxicity in 3D printers, like with VOCs and what's the output, especially of an SLA printer.
Right.
I think is what you're monitoring. But I don't know if many of our listeners may not know about this. But so 3D printers, when you heat up plastic, they kind of like outgas in a sense. And you may be able to explain this better. To my understanding, though, is that they outgas these little tiny particles along with different toxic fumes that come from the plastic. Now, it's not as much as people would think, but it is notable with a lot of 3D printers. And with that, I know SLAs are pretty bad, but what about, like, say, FDMs? Or can we just talk about that episode as a whole?
Sure. As part of, I guess, the videos that I make, I also do some 3D printer reviews, and then also, try to benchmark them and try to test them. And back, I would say, maybe about 2 years ago now, this company contacted me. His name is Elegoo, and at the time, they made this new printer called the Mars. And at that time, basically, resin printing was relatively new. It was kind of at the stage of maybe early FDM printers where you could buy a commercial product and you didn't necessarily have to like build it yourself with a UV light source and like a plastic tub to basically expose something, but it was like this product that you could buy, and a lot of people were really impressed with it just because the resolution that you can get on an SLA machine, I mean, it's so much higher than something that you can get on an FDM machine. But as these units were coming out, and as you said, so as opposed to like a filament spool that you would have on an FDM machine, a resin printer uses essentially liquid resin. And then what happens is the way it builds the model is it exposes one layer of resin to UV light at a time. That then hardens the resin, and then slowly, it again, much like FDM printing, it builds up an object layer by layer, but in the case of resin printing, out of this liquid resin. And because it was fairly new, a lot of people had basically questions about how safe it was. And online you always see, you always want to wear nitrile gloves, and two, you want to make sure that you don't use it inside the house or not inside of a well ventilated area. So what I wanted to test was really to see kind of how much how bad the fumes are and how many particles these printers emit into the air. What I did is I bought an air quality monitor, which is basically a particle counter that measures both the particle count and VOC emissions, and then kind of compared to see kind of the particles that get emitted into the air. So I have not yet tested FDM printers kind of with that, but certainly with the resin printing that I did in that test. So they did emit quite a few particles and some VOCs. So definitely you should probably use them with the window open as they said. But one of the things that was interesting from that video is that another printer that I was comparing it to basically had an integrated carbon air filter, and that cut down on the emissions pretty significantly. So it's nice to see basically that as a technology is maturing, it's definitely getting safer. And I'm hoping that by making videos like that kind of explain the basics of kind of the underlying technology, and then investigating too maybe some of the things that people are concerned about when they're using it, to inform people to make sure that they're using a technology safely, but then also to provide feedback to the companies that send me a printer about how they can improve their product, and again hopefully also make it safer for the user.
That's very well said. Yeah, that's really cool that you're doing that, because that's always kind of a curiosity of mine. You hear all these different things across the internet, even about GAC filters in general when it comes to how they're able to filter out some of the things for 3D printing, and we know to what quality can they filter them out. So it was cool to see, especially in the episode, that you kind of dove into that and talked, worked through it and saw that filter actually did some serious good for that. So of your projects, you got a lot of projects, going on Super Make Something. What is your favorite 3D printing project that you've completed thus far?
So thus far, really the ones that I like are, the ones that kind of combine something robotics related, with electronics and with 3D printing. So of the projects I built, I think the one that I use most every day is the Alexa controlled light switch. So what this one is, it's basically an internet controlled microcontroller that connects to your smart assistant, and basically, what that does is it waits for a command from your smart assistant to be sent basically over the internet to this microcontroller. And then what it does is it controls a servo that's attached to a 3D mounted or 3D printed rack and pinion that's then mounted on a light switch. And that basically turns the light on and off, and the whole thing is battery powered, and you can basically just kind of set it and forget it. And what I like about that is, in grad school, having lived basically in an apartment where you couldn't really kind of install like a smart light switch or modify anything, because you weren't able to, I guess you didn't own the property and you just rented the property. I liked basically that you can design something with 3D printing that still allows you to kind of use like this cutting edge technology, like, an internet enabled light switch basically. And you can kind of build a mechanism that solves or that accomplishes the same task, but then use it for your purposes. So again, just because this kind of sticks onto the wall without modifying anything, you can basically use it for any light switch in your house, and you don't have to kind of play with the main power lines in your house, and you don't have to install any light switches. You literally just download the code, solder the servo to a breadboard, and then insert it into this 3D printed mechanism, and now you have a 3D printed internet-enabled light switch. And I think things like that really excite me, just because it shows that, with kind of this very kind of consumer level set of tools that are available. So, just a standard FDM printer, a relatively cheap internet-enabled microcontroller, and a servo motor, you can do these crazy projects that, 10, 15 years ago, would have been unthinkable. And it just shows kind of how fast this technology has progressed. And I think, shows the potential of, where we'll be 10, 15 years from now, if we can already do things like that with consumer level technology now.
Yeah, and honestly, I totally agree with that. It's so cool to see, what would have been previously just like kind of like a dream, just, oh, this would be super neat to be able to put this together. Some inventors thought that could have taken, months, if not years, to build some of this stuff. We can now do in almost like a weekend. Exactly. That was like, that was like a large portion of, when I first got engineering, I went to this summer camp and never really touched programming at all in my life. And then the team and I, we put together this little Nerf gun shooter thing that just monitored the area around it with a little radar. And if anything got into space, it just, would shoot the Nerf darts out, and so like previously, that would have been quite the crazy project, but us, a bunch of us who had never really touched engineering before managed to dive into that, and we were able to put this whole thing together, and we did pretty well in the competition, if I do say.
That's excellent.
Yeah. But yeah, honestly, I need to check out that episode, because I've been trying to. I have an old speaker set, old Bluetooth speaker set, but you had to still have to manually turn on some buttons and whatnot to get into it. And I've always been able to wanting to just have like a remote from far away, so I might have to check that episode out.
And that's one of the other things that I like. So with 3D printing, back in the day, like you had said, if you wanted to have something like, for example, your stereo, if you wanted to push a button, the solution, would have been, oh, now I have to buy a new stereo. I have to buy a new receiver with a new remote that has that functionality that I want. But, now with 3D printing, with a little DIY and a little bit of ingenuity, you can really repurpose and extend the life of a lot of the things that you own. So for example, again, like with this light switch, I didn't have to go and switch out every light switch in my house. I just 3D printed literally this little add-on stuck into the lights that I wanted to be smart. And basically had that done in an afternoon. So I just to be able to do that, I guess I like the concept of that, just because, it kind of also reduces waste and reduces the need to basically throw out, perfectly good electronics because maybe they're missing the latest feature. But now with 3D printing, and especially now that, things like CAD tools are becoming free and open source and easy for anybody to use. it just democratizes basically hacking, I would have to say, and it makes it so easy and so approachable that anybody that has any idea or really wants to solve any problem, I mean, can literally now do it from home at home without a machine shop, and that just blows my mind every day.
Oh yeah, exactly. I mean, just like you said, it democratizes it. You know, everyone can take part in it. Everyone can push it forward. And that is just, I mean, it's part of the reason I got into engineering is because I wanted to make all these, you know, cool projects when I was younger, but I was so frustrated by not having the ability to do so. And then now it's like, yeah, you don't need a machine shop anymore. You can just, you know, print things, put them out, and you can develop these fairly cheap electronics. I mean, I was shocked by how non-expensive a lot of electronics are. And especially to build like little robotics projects, fairly affordable to build a lot of these really cool projects.
For sure. And I think a lot of that too, you know, comes from basically these economies of scale that we're seeing now with these hobby level FDM printers. I mean, a lot of them use the same standard components, right? They use stepper motors. A lot of them are based in Arduino. And that just means that, you know, companies make a lot of these components and basically make them available to everyone for really, really cheaply. So now, I mean, you can, you know, buy a stepper motor for, you know, $10. You can buy an Arduino for $2, $3. And with that, I mean, you can make a robot with some 3D printing. And just as a kid, I know, you know, I guess had this technology existed a little bit earlier, I know that I would have definitely been all into that, and, you know, gotten an earlier head start, I guess, into engineering than I did. So I'm really excited to see kind of what this new generation does, that has really had kind of all these tools available to them and really grew up with them, so they're second nature, just to see what they do with it. And hopefully that's going to lead to a whole new generation of engineers that are, you know, more capable of anything that, you know, we ever thought that would be possible. So
Yeah, honestly, the innovations that I think that are going to be coming out in the future here are just going to be unimaginable. I mean, it's just the limits are endless when it comes to what you can do for such a low price. So on that, where do you hope to see the market go for 3D printing?
right. So it's so tough to say, just because, you know, I've seen, I guess, since, again, getting started in FDM printing with this PrinterBot Simple, still seeing kind of the same underlying technology, which is just, you know, a bunch of stepper motors move a nozzle to deposit plastic. And that concept has just evolved so much over the last 8 years to things that now, I guess, you know, they make these belt printers with essentially a quote unquote infinite Z height, where you can just print these massive objects. And there's just these new innovations coming out every day where, you know, people basically take this technology that exists already and just tweak it and just hack it and just innovate with it. I'm just excited to see what's coming next. I mean, obviously, you know, people always say, oh, like, I wish the printer would print faster, or I wish, you know, that maybe it wouldn't be so difficult to remove support material from a print, for example, and it'd be more approachable from that way. But honestly, I'm just excited to see where it goes, just because it seems like every few months you get this new I guess, technology that's incorporated into all these printers. Like now, for example, almost every printer has automatic bed leveling, and every printer has a heated bed. And just these kind of pro level features that are now integrated into these consumer level machines, just makes me really excited just to see what, you know, 3D printers that even come out next year or the year after that will be capable of, that are, you know, currently reserved for, you know, multi-$1,000 machines. So
Yeah, it's really amazing how fast the world of 3D printing, especially in the consumer side for the cheaper printers, like say like sub $1,000 printers, is innovating. I mean, it's just it will not stop. I mean, like I said, auto bed leveling, some of these features that previously were, I mean, because I mean 3D printing has, you know, its history is a little bit longer, I think, than a lot of people recognize. You know, since consumer printing came out, what, in the early 2010s, I believe, and then but before that, we've had 3D printing at some places since like the 80s. And I know NASA, I believe, has been fairly involved with 3D printing for a long time overall. But yes, it's amazing how fast, now that it's in the consumer domain, how fast these smaller little printers are just, you know, this constantly, there's like, yeah, as you said, there's new features coming out all the time. What shocked me the most, I think, is the number of filaments.
yes,
And what people are putting through 3D printers, like foods and stuff like that. I just saw an article recently about different like meat replacements that are being 3D
Oh,
printed,
wow.
and like the
Interesting.
quality is like a quality comparison, which to me means that it's not just the cool fact that they're 3D printing, food. It's gone to the level of comparing that food. What's better? That was just like shocked me. So it really is really cool to see where everything's going and all the innovations that are coming out here.
Yeah.
Like you said, I mean, it's really cool, and I am also very excited just to see where it goes, because I honestly, if you would have asked me, a few years back where you saw 3D printing going, I would not have said, my number one thought would not have been the food, quality
Right.
comparison for like for restaurants,
Hmm.
yeah.
That's a good point, actually, with the filaments. So, kind of going back to grad school, one of the projects that I was involved in was basically 3D printing elements for this new torque sensor and these robotic actuators that we were building. And back in the day, those were the polyjet printers that we used to basically print clamps and to print molds, and then we had to use rubber to cast basically the spring element that we wanted, and then we had to kind of clamp that in between these 3D printed clamps that we had made. But now, I mean, not only do you have this kind of new material, for example, now you can 3D print TPU rubber, and it's super compliant. They make a bunch of different types of materials with various different properties and various different hardnesses and things like that. But now you also have multi-material printers, so you could, in theory, instead of having to kind of 3D print something, cast it, and then kind of assemble everything, I mean, you could probably 3D print a lot of mechanisms just in place with a dual material printer, which is, again, mind blowing that that's now a consumer technology that exists for under the $1,000 mark, where you can print two materials at a time and just make these crazy complex mechanisms that would have literally been impossible to make even 10 years ago, just with additive manufacturing. It's
Hmm.
awesome.
Yeah, and like you're saying, like the rubber one, that also shocked me, being able to see that, just in the whole process of what 3D printing is, but also the fact that you can make rubber elements out of that, like flexible ones of different material types and whatnot. I think the one thing that I do really want to see, especially in the consumer side, specifically for FDM, is 3D printing of optics, because
Interesting.
optics is such a difficult area. It's such a high expense area when it
Hmm.
comes to working on projects. Like if you go hop on Thor Labs, Redmond Optics, and you want like some high quality optics to do a project on, it's expensive. I mean, it's
Hmm.
ridiculous sometimes what these places charge you, but I mean, that just shows the market right now. But so if that kind of stuff was brought down for prototyping, specifically for optics, oh my goodness, I mean, it'd be so cool to see what all could happen. I mean, people could start making, photography lenses or whatnot.
That would be
Um,
cool.
but yeah, so that's
Wow.
one of my hopes to see, is because there are clear PLAs, and I've
Hmm.
seen some people dabble in FDM printing of optics, but yeah, so hobbyist level optics. Please, someone, whoever's listening, if you had the ability, bring it to life. So, with all of your experience in 3D printing thus far, what are some tips or just some lessons learned that you could share with the listeners?
Sure. So, especially for anybody looking to build components, I would say with 3D printing, definitely prototype a lot, prototype often, and then also, before you finally send something off to be manufactured out of the material that you need for a project, just do a final print just to verify, size, fit, and just to be able to hold it in your hand and just spin it and look at it from all these different angles. And that's just invaluable to me. I mean, a lot of times, you're working on these CAD assemblies on your computer, and then you print it and you're like, oh wow, like, is that what size that is? And kind of it's easy to get lost kind of in the scale of things when you're working with them on a computer. So being able to hold them in your hand is very useful, I guess. So definitely that would be my first tip, is that people shouldn't be afraid to prototype, and should make sure to prototype often. The second thing that I would say is, especially for these hobby level machines, I think a lot of people that are just getting into CAD, and try to print an object, are often disappointed because they'll design a piece with really complicated geometry, and then it's difficult to remove support materials and things like that. And with these single filament printers, that can oftentimes affect the function or the form and the surface finish when you have to go in there and just pick out a bunch of support material, and that can be kind of annoying. So my other tip would be for people that just get into the hobby, is to try to design your parts in such a way that you can avoid using supports, and also kind of be creative in the way that you orient parts on your print bed to make sure that they have strength in the correct direction based on the way that the layer lines are laid down. But then also to not be afraid to marry that 3D print that they make with something else. Like, for example, add a fastener to it, or add a nut to it and embed it in the print, and now you basically have kind of a high hold part that's got metal hold embedded in your 3D print. So definitely, I would encourage people to not be afraid to kind of experiment with 3D printing or try to do everything with 3D printing, but really just to play with the limits of what they can do, and not be afraid to break their printer, just because in that process of designing something and just playing with new things, I mean, oftentimes the failures that you have are so much more informative than if you just print something and say like, oh well, that worked well, and then you don't really think about it anymore just because it works. But really the ones that fail, and you have to analyze why it failed so you can then iterate on that design and create something better, that's really where a lot of the learning takes place. So I guess that would be my my top tip is, I guess, if you 3D print something, don't be afraid to fail. There's a chance that your first print might work, and that's great. But if your first print doesn't work and you have to do print 2, 3, 4, and 5, don't get discouraged, and just keep trying, and just be excited about all the new things that you learn, and that'll help you make the next project that you design better.
Hmm. Yeah, and just on that, I think if you're a curious person, I think 3D printing is a lot of fun because it just, if you're a curious person when it comes to and being okay with failing, because you learn so much through the various different things the prints as they do fail. Like for me, when I first, because I come from like an electrical side and also an optical side, not really a mechanical side of engineering. So when it came to printing the fine details and realizing that an FDM printer, it might expand a little bit, and then it offsets your optic by, like a tenth of a millimeter or something like that. Things I never would have thought of, or thought, the resolution is fine, but things I've learned over time. There's also two other key notes that you said there. One of them was printing in the direction for the strength of the filament. And I think that's specific more so to like FDM printers,
Mm-hmm.
as SLAs are more overall combined. But I think that's a very key feature there, about 3D printing that I thought was really cool thing to note. Yeah, so, and then also with embedding parts, that's one thing that I never thought of when I first got into 3D printing, was to like, oh, I can still actually use hardware.
Right, exactly.
I can go to Home Depot and still buy a nut and screw and then incorporate that into my print. I don't know why that took me so long, but that's a very key facet of all this. So, very good points there and great tips for all the listeners there, especially those getting started in this area. So finally, what are some tips, since you are very passionate about this area and teaching people how to get into 3D printing or electronics or robotics? What are some tips for young listeners who are looking to possibly dabble into this area? They're a bit intimidated by it. What are some tips for those people to dive in head first and just to get really embedded into this area?
Sure. So I think the biggest tip that I can get, and it's not meant to sound cliche, but honestly, the best tip that I can have is get started. And what I mean by that is, try to find a project that you want to build that you'll be passionate about. So for example, if you want to say like, oh, I want to build a wheeled robot, but you don't know where to start, basically, hop on YouTube, look around what you can find, get some ideas. And then in that process of you getting started on that project and maybe making your first 3D print, and kind of learning the bare essentials, what you need to make that project work, is you'll basically end up learning more and more as you continue going. And just by having a project that you're really passionate about, that you're willing to see through, it'll keep you motivated to keep going, but you'll just not only pick up so much new information along the way, you'll also kind of notice maybe other topics as you look, for example, into microcontrollers. Like, you're like, oh, what are transistors? Transistors exist, and now you know that they exist, and maybe you'll stash that information away. But then maybe a few months later you come back to it and you're like, oh wow, I remember what a transistor is. Let me look more into that. And you realize that you can use that for a project. And basically, just by kind of starting a project and then just following that path through completion, and having this exposure to all these other projects or all these other topics, you'll basically create this little knowledge tree where you can just branch out in all these different directions. And with every project that you make, you pick up a little bit more information by learning like about a key aspect that you need for a project that you didn't know before, but that knowledge is cumulative, right? So by the time your fifth or your sixth project rolls around, you have now this whole new arsenal of knowledge that you wouldn't have had before, just because you decided to start on this one project that you were passionate about at the beginning. So I would say, even though it can seem scary, my number one tip would be try to find a project that you're really interested in doing. Don't be afraid if you think that it's maybe you're biting off more than you can chew, but just get started, start exploring that topic. And then by exploring that topic and kind of hitting brick walls that you need to kind of research more about further to solve a problem, you'll just learn so much stuff. And over time, you'll have this great new collection of engineering knowledge and maker knowledge about all these different topics that you would have never thought about when you started out. And I think that overall is kind of the best way to learn. So
it's very true. Diving into those projects and developing that knowledge tree, best ways to get into things and learn about them. And that's a very good point that you made there about from project to project, how much you learn, how much you can transfer over. That's one thing, I never thought of when I first got into it all. But, once you start tackling on all these little smaller projects, they eventually do build up and you can do some crazy things over time that you never thought you could, but you have, once you develop up that knowledge tree and just take that from project to project and just learn more things. So what a wonderful area. And so, Alex, how can we find out more about you or what you do or just keep up with you?
Sure. As for the work that we're doing at NASA in the Slope Lab, definitely check out the NASA Glenn YouTube channel. So we are in the process of kind of a lot of testing for an upcoming lunar mission that we're working with NASA's media team to generate a lot of content and to kind of explain the work that we're doing there. So definitely keep an eye out for that. For more of the Super Make Something maker topics, definitely check me out on YouTube at youtube.com/supermakesomething. And that'll basically take you to a page where I list videos for all of my projects. And that it's also a good portal for other locations where I am on the web. So for example, for GitHub, where you can download all of the 3D printable files and all of the code that I build for my projects. And it'll also take you to kind of Instagram and Twitter and all those behind the scenes things. So definitely I would say check out YouTube for both of those, and be sure to stop by and say hi.
Thank you so much for sharing that, and I'll look forward to seeing what you do at the Slope Lab and also for the new episodes that are coming out in Super Make Something. So Alex, thank you so much for hopping on today for this podcast and talking through everything. What a wonderful conversation about what's going on at NASA, and then also about Super Make Something and just the really cool areas of 3D printing and how people can get involved in that, and just the cool different facets and features as this technology progresses. Thank you so much, and have a wonderful evening.
Yeah, thank you so much for having me on. It was a lot of fun.
Thank you for tuning in to this week's episode of The Next Layer, a podcast for all things 3D printing. If you really enjoyed this episode, we ask that you please share it with all your friends, subscribe, and leave us a review. Thanks again, and we hope to see you at The Next Layer.